Hi, this is Dr. S and this is video 3 in my series on reaction rates for Year 13 A-Level Chemistry. This video is about the rate constant, which we introduced in the previous video as part of the rate equation. The rate constant is the K in the rate equation, and this video will look at how to calculate the value of K. So just to remind ourselves, our rate equation looks like rate equals K, the rate constant, multiplied by concentrations of the reagent raised to the power of their orders. And that can carry on for as many reagents as you have. So what we're going to look at today is how to calculate K. In order to calculate K, we would need values of the rate and the concentrations of the reagents. You would determine all three of these things experimentally. So you can carry out an investigation, obtain the value of the rate, obtain the concentrations, and then work out the K from that. So let's look at how we would do that. Let's say we had a reaction, A plus B makes C. A is a first order reagent and B is a first order reagent. And I'll say that the concentration of A is 0.1 mole per decimeter cubed and the concentration of B is 0.2 mole per decimeter cubed. And we'll say that the rate of reaction is 0.04 mole per decimeter cubed per second. I'll just clarify that that is moles per decimeter cubed there. So the procedure we would need to do to calculate K is, firstly, we'd need to calculate the rate equation. So the rate equation here, these are both first order. So it'd be rate equals K, concentration of A, concentration of B. Now I need to rearrange this equation to make K the subject. So if I divide both sides by A and B, then I isolate K. So K becomes rate over concentration of A, concentration of B. So if I now plug some numbers in, K equals 0.04 divided by 0.1, which is the concentration of A, times by 0.2, which is the concentration of B. And if you run that through, you should get an answer of 2. Okay, so that's the numerical value. What we now need to look at is how we work out the units of this. So let's start on a new fresh piece of paper and try and work out the units. If K is rate over A, B, then what we can do is think about the units of each of these things. What we have is the rate. The unit of rate is moles per decimeter cubed per second. And the units of these are moles per decimeter cubed. So moles per decimeter cubed times by moles per decimeter cubed. And what we should be able to see here is that the moles per decimeter cubed can cancel out. So this one, this mole per decimeter cubed here, and this mole per decimeter cubed here can cancel each other out, leaving just these two. Now moles per decimeter cube here, is on the bottom of the equation. So if I want to take that up to the top, I have to invert the indices. I've got to imagine that that is a mole to the power of 1. So if I want to take that up to the top where the seconds to the minus 1 is, I need to make that a minus 1. I need to make this a positive 3. So effectively what I've got is moles to the minus 1, decimeters to the positive 3, and I've still got my seconds to the minus 1. Now convention tells us that the positive index should come first. So actually the proper units here are dm to the 3, mole to the minus 1, s to the minus 1. You won't be penalised in an exam if you do this, but this is the correct way to do it. So the units of K in this case are dm to the 3, mole to the minus 1, s to the minus 1. Now if you've been sharp, you might have noticed that there's not always 2 concentration terms on the bottom. So actually the units of K can be different. So we'll look at some examples where they are different. So let's just put that all together with the previous question. And now the units of my rate constant were dm to the 3, mole to the minus 1, S to the minus 1. Okay, so that is a way of calculating a relatively straightforward rate constant. In my next video, I'll look at more complicated ones and I'll give you some examples to try yourself. Okay, I'll see you then.